learning objections. Different forms of equations of lines. What are the different forms? That's slope-intercept, yep. There's point slope, like y minus y1 equals m times x minus x1. Standard form is the other. Ax plus by equals c. And then there's vertical line, x equals k, and horizontal line, like y equals k. Things you already know. Ooh. Gradients. When they say gradient, what do they mean? Slope. That's just IB for slope. What's the slope formula? M equals y2 minus y1 over x2 minus x1, right? Intercepts. What do we mean by intercepts? Where the graph crosses either the x or y axis, right? Ooh. Parallel and perpendicular lines. How do you know if two lines are parallel? Their slopes are the same, and their y-intercepts have to be different, right? Because if they are both the same, then you're coinciding, you're intersecting everywhere. What about perpendicular? The slopes have to be negative reciprocals. So like 2/3 and -3/2. Concept of a function. Domain and range. Graphing a function. Function notation. The concept of an inverse function. Key features of a graph like x and y intercepts, vertical and horizontal asymptotes. Using technology to find the intersection of curves or lines. These are like the learning objectives for this chapter. This should all sound like, hey, I already know how to do this stuff. Is that okay? Yeah. Let's go review and kind of do some examples of things that you'd be expected to be able to do, right? Okay. So let's say we have the equation a squared plus b squared equals c squared. And we want to solve for b. How do we do that? Who can tell me the first step? Subtract a squared from both sides. Love it. Next step would be square root both sides. What do you have to remember when you square root both sides of an equation? Plus or minus. And we're done, right? B's by itself. Great. How about this one? Solve for L. T equals 2 pi square root of L over G. What should I do first? Divide by 2 pi. Okay, then what? Oops.
Square both sides.
Square both sides. And then last would be to multiply by G. Now, what if I write it this way? Are you okay with how I got to there? Okay. This is the hard one. What if I want to solve for R? Notice what's different about this problem than the previous ones. R is in 2 different locations, right? Ooh, scary. They do not just cancel out. You can't reduce a fraction where there's addition and subtraction. You can't reduce part of an addition or subtraction problem. I'd multiply both sides by R plus r, or big R plus little r, to get rid of the fraction. Now what do you want to do? Let's put both big R's on the same side. I don't want to divide by r, but I'm going to instead factor the r out. That'll make the r from two different locations to one location. That's the key. Every time you see something where you have a variable in multiple locations, you're going to have to factor. And then to get the big R by itself, we're just going to divide by n minus I. And that'll do, right? You guys vaguely remember doing that kind of stuff? Yeah. Okay. So a review of the different forms of lines. So we can write an equation of line. This is the IB vocabulary. This is why I included it, because their terminology is different than our standard American terminology. So when we say standard form, they're going to say general form. When we say point slope, they're going to say slope intercept. They're going to say gradient intercept. And where we say point slope, they're going to say point gradient. Whatever. The formulas are the same though, right? Does that mean you have to remember that gradient means slope and general form means standard form? Sure, you have to remember that, like a little bit of translation. But these are formulas that we should remember. Plus, they'll be on the equation sheet for you. All right. So, what if we wanted to sketch the line for each function? How should we do this? Okay, you could do that. So for the first one, we're going to subtract 5x, add 6, and then divide by 3, right? Great, now what? Probably now make an XY table to find some points. How many points do we need to graph a line? 2 is enough. So let's pick a value for x. What's a good x to pick here? I would not pick 1. You could, it would be fine, but let's not. What's wrong with picking 1? You're gonna end up with a fraction, right? My goal really in doing this is I'd like to do it in a way that I don't have to deal with any fractions if I don't have to. What's the best x to pick almost no matter what? 0. When I plug 0 in for x, what does y have to be? 2, right? Because just negative 5/3 times 0 is just 0, and you're left with 2. What's another good x to pick here? I would not pick 2. I'd want to pick an x that's a multiple of that denominator. So when I multiply it together, I don't have a fraction. Now, 1, 2, those are fine to pick, but you have fractions left that you have to deal with, and I don't want to have to graph fractions if I don't have to. So let's use 3. What's negative 5/3 times 3? Negative 5. And then I have plus 2, so that's negative 3. Can I trust that you guys feel comfortable plotting points and drawing a line? I'd like to imagine that's a world we live in also. How about this one? What should I do first for B? Okay, so get y by itself again. What do you notice that's weird about this one? There's no x in it. What does that mean? It's a horizontal line. That means no matter what x you pick, the y is just always got to be 4. How about this one? What would we do here? Okay. There's no y in this one. What's that mean? Yeah, no matter what the x or what y is, x is -3, so y can be, doesn't matter. It's not in there. It can be whatever it wants. Everybody feel good? And we're not going to graph these because, goodness gracious, Mr. Kulik, I'm a senior in high school. I can plot points and draw a line. That's fair. I know that's a slippery slope I'm climbing, but I think we're going to be okay. I brought my grippy shoes, so. Here, this one says find the equation of the line that passes through the point 3, 31 and has a slope of 12. Write the equation in slope-intercept form. I'm going to say slope every time they write gradient. Is everybody okay with that? All right. You remember how to do this? Slope-intercept form is that, right? What are we told? Slope is 12. What am I going to do with that point? That's the other piece that I'm given, right? That's an x. That's a y. Three times 12 is 36. I subtract 36 from both sides. I get b is -5. But remember, we're not done because we need an equation for a line. How do I write my final answer here? Y equals 12x minus 5. Very good. Again, has to be an x and a y in our final answer, right? Find the linear equation in C and F, knowing that when C equals 10, F is 50, and when C equals 100, F is 22. Write for F in terms of C. Anybody can tell by the numbers what C and F are? Well, they're going to represent X and Y for sure, but they're Celsius and Fahrenheit temperatures. I can tell because C was 100 and F is 212. That's the boiling point of water in Celsius and Fahrenheits. Now that's immaterial to doing this question, but yeah, so which one is going to be which? X or Y, F and C, which one is which? Does it matter? It definitely does. If we're looking for F in terms of C, F should be my Y and C should be my X, right? Like we've written the other equation for Y in terms of X, because the Y is by itself and it equals something, expression with X in it. Everybody's okay with that? All right, so this is like an XY, and this is like a second XY, right? What am I going to use that to get? Very good, the slope. So write 212 minus 50 over 100 minus 10. So what is that? That is 162 over 90. that reduces to like 7/5 or something. 9/5. So far, so good. Now what do I do? I plug that into what? Okay. Right. So we'll say C equals, or I'm sorry, F equals F equals MC plus B. What am I gonna, so M we know, what am I gonna put in for F and C?
F is 2.
Great. Could I have also used the other one?
Yeah.
The 50 and 10? Does it make a difference? Shouldn't. 9/5 times 100 is 180. And when I subtract 180 from both sides, I get 32. Does that make sense? That when C is 0, F is 32? Yeah, right? C0 is the freezing point of water in Celsius. 32 is the freezing point of water in Fahrenheit. That feels like that worked out pretty nicely for us. Again, immaterial that you recognize that to do the problem, but like helps give me a little intuition about whether my answer is any good or not. God bless you. You're welcome. Let's say we have the equation y equals 3/5 x plus 2. What is the slope in y-intercept? Great. It says find the equation of a line that passes through the point 1, 5 and is parallel to the given line. So right away, what does my slope have to be? 3/5. And we know our point is 1, 5. So what do? Same kind of thing that we did before, right? Everybody feel okay in how I did that? What if we ask for a line perpendicular to that point 1, 5? What's the slope have to be? -5/3. And we do the same thing, right? Everybody feel good doing that? Again, like, should be like Mr. Kulik. We did this in Algebra 1. Are you serious? And I'm like, I guess I'm pretty serious. We'd be spending all this time if I wasn't. I'm happy that you remember, though. Next one says line L is given by the equation 3y plus 2x equals 9. And it says point P has the coordinates 6, -5. Explain why point P is not on L. This is very easy if you know what to do, very difficult if you're unsure what this means. Here's what I would do. I would just show that 6, -5 doesn't satisfy the equation. And I'm done, right? No words necessary. I've just shown that the point doesn't satisfy the equation. That ought to do it. What's going to be the easiest way to get the gradient for that line, 3y plus 2x equals 9? Let's just put it in slope-intercept form, right? And then the slope should be staring right in our little faces. Okay, so what is our slope of the line perpendicular to 3y plus 2l equals 9? Positive 3/2. And if I want the line that's perpendicular to L and passes through that point 6, -5, well, that's not too bad, right? So that gives me 9, so I subtract that over, that's -14 for B. Seem okay there? Hopefully still feels pretty easy, right? All right. Who remembers how to use their graphing calculator to solve a system of two variable equations? What should I do first before I type this into my calculator to graph it? Yeah, we gotta get y by itself, right? Do that real quick for me. Make sure you still remember how to do that, if you would. No?
Is it just you plug it in?
And then you use the intersect command, so second trace. Pick the intersect command, and you can just press enter 3 times from there because you only graph 2 things and there's only one intersection. What's the other way we could do this on our calculator? What's the other way you could do this problem on your calculator? You could use a matrix. Remember doing that? That's Mr. Kulik's preferred method because it doesn't matter, it doesn't have to be a 2 variable to make this work. So we should have a 2x3 matrix because I have 2 rows, because I have 2 equations, and 3 columns, one for the x's, one for the y's, and one for the solution. Then I do just the coefficients, so 2, 3, 6, 2, -1, and -10. And once I've got my matrix entered in, I exit back out to the main screen, go back to that matrix menu, this time to the Math tab, and the command I'm looking for is RREF. Be careful, because you don't want REF, you want the stutter, the RREF. And we'll do that on that matrix A that we just made. And there is our column, -3, 4 is our solution. I forgot to write the negative sign on my 3, it looks like. Oops-a-daisy. Practice on the next one. Use your calculator. Do the matrix thing on the part B. Real quick, if you're good, it just takes a minute just to jog our memories on how to do this. Super helpful technique because it's super fast and super accurate. Yeah, of course. What's the one hitch with the matrix methods? The setup matters. You have to have the x's lined up vertically. The y's have to line up vertically. The equal sign has to be next. And the solution has to be by itself. If it doesn't look like that, you'd have to rearrange it to make sure it looks like that before you can enter it into your calculator. Most of the time, that's probably what they'll give you. But we need to mention at least that you have to be careful about that. All right. You guys remember how to do elimination to solve this by hand? What's the idea here?
You know, I did, like, you multiply 1, like the first 2, 5,
Close. One of them has to be negative, right?
yeah.
So let's do -2 and then +5. But that'll work. Or if you had elected to try to eliminate the y's, you could have just you could have just multiplied there by positive numbers because one of them was already opposite signed. Does it matter which variable you eliminate first?
No.
No, man. What do you do once you get an answer? Plug it back in where? Any two variable equation, right? So I'm going to plug it into the second one. Everybody feel okay there? In general, I prefer elimination over substitution because I have a lot more control over when I get a fraction, when I don't. Substitution, oftentimes you're going to be forced to confront fractions when maybe you'd prefer not to have to do that. So if we try doing the next one, substitution, how does that one start? You pick one of the equations, and you want to get one of the variables by itself. Now, here's a case where sometimes if you're observant, you can avoid having to deal with some fractions. That would be the case here. Which equation, which variable would be best to use to avoid fractions? Equation A, and look at what variable? Get the y by itself, right? Should be real easy to see that. So I'll add y to both sides and then add 9 to both sides. And then I'll substitute that into the second equation. So I'll replace the y with the 3x plus 9. So that's going to give me x equals negative 4/3. What do I do there? Yeah, I'm probably going to plug in here because the y is already by itself. You guys remember doing that? I think in general they probably won't ask you to do one versus the other, but it's very likely you'll get a multi-step problem where one question asks you to like solve this equation in terms of this one to like set up a substitution for the next part. Like that is very likely something they would ask you to do. You know what I mean? All right. So let's look at some function stuff. So it says express the volume V of a cube as a function of the length E of each edge. Who remembers how to calculate the volume for a cube? Times. Yep. So in each of those cases, length, width, height. So my function notation, V of E would equal E cubed. Is everybody okay with that? So I used the function notation there. That doesn't mean V times E. That means V as a function of the variable E. Okay. Express the total surface area S of a cube as a function of the length E of each edge. When I say surface area for a three-dimensional figure, what am I talking about? The sum of all the sides, though, right? So how many sides does a cube have? 6, like a regular dice, right? Like a Monopoly dice. Okay? And what is the area each side is the same, right? So how do I find, what's the area of one side? E squared. And we have 6 of those. So it should be 6e squared, right? Everybody feel good on how we did that? Again, I didn't write much down. We just kind of talked it out. That felt enough. All right. Domains and ranges. So the first function is given as a set of ordered pairs. If I want the domain for that first function, how do I do that?
Take like the lowest x.
It's not just the lowest x. Not just that. It's all of the x's. Okay. One thing we should be clear, when you list a domain, no repeats are allowed. Even if the x coordinate is used more than once, you only write it the one time. Item number 2, this is a set, so it must have a set bracket around it. If you don't include the set bracket, I will mark it wrong. Everybody's okay with that? A domain is a set. It must have the set bracket around it. How about the volume of a sphere, where the volume function is v equals 4/3 pi r cubed? Maybe we'll say this. Probably be written that way in the back of the book. The x's in my domain are a member of the set. Blah, 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 blah. All right, so if I look at B, the independent variable is the r, right? R is representing what real world quantity? A radius. How do we measure a radius? No, I mean like with like what kind of units?
Meters.
Yeah, it's a length, right? Okay, so what is the smallest possible length we could have for a radius for a sphere?
Just above 0.
Just above 0, right? So we'll call something with 0 radius not possible. And then how many lengths after 0 can we have? Infinitely many, right? So we're not going to list that as a set. We're going to list it using an interval notation. So the lower bound on my interval is 0, and the upper bound should be positive infinity, right? Now, when we write these intervals, remember that the bracket versus the parenthesis mean 2 different things. Bracket means that number is included in the set. Parenthesis means that number is not included in the set. An infinity always gets a parenthesis rather than a bracket. And we chose to use a parenthesis at 0 because a sphere with radius 0 wouldn't actually be a sphere, right? That's just like a single point. And we didn't want to include that. But if it had radius of 0.00000000001, well, we want to include that. So it's just like everything above 0. Is everybody okay with that? Alternatively, you could have also written it as like the set of x's such that x is a real number and x is greater than 0. I don't know. I assume in the back of the book they're just going to leave it as an interval notation, but I haven't looked back there recently to see how they wrote it. But my suspicion is in intervals be what they would give you. All right. Here's the next one. We have an equation, right? So my goal here when I get an equation is I want to think about the operations involved. What operations are involved in this equation? Y equals 5 over 2x minus 6. I see division, good. What else? Subtraction and multiplication. So let's go through these operations one at a time. If I take any two numbers and multiply them, am I guaranteed to get an answer? Yes. So multiplication isn't going to matter to me. If I take two numbers and subtract them, am I guaranteed to get an answer? Yes, it can be negative, right? But that's okay. Third option, if I take two numbers and divide them, am I guaranteed to get an answer? No. What specific division problem gives us issues? When we divide by 0. So to figure out my domain, I'm going to take the denominator or the divisor of my division problem and say that I know that that cannot be 0. What value can x not take then? 3. So how do I write everything except for 3? Well, I start at negative infinity, and I go to 3, but I don't include it. And then I restart at 3, but don't include it, and go up to positive infinity. Is everybody okay there? All right. Let's do the next one here. So starting the same way, we have y equals the square root of 3 minus x. What operations are involved in that function? Subtraction and square root, right? Now, subtraction we already talked about, no issues there. Square root, can I always take the square root of a number and get an answer? No. What kind of problem, or where can I run into problems? Square rooting negatives, right? So I know then that the stuff underneath my radical has to be non-negative. So greater than or equal to 0. Because what's the square root of 0? 0. That's a problem we can still do, right? Okay. So to get the x by itself, we'll subtract 3. And then when we divide by negative, what do we have to remember? Yeah, the inequality changes direction. So now if I think about this, what does this say? It says x is less than or equal to 3, right? Is 3 the biggest number in that set or the smallest number in that set? X is less than or equal to 3. Is 3 the biggest that x could be or the smallest x could be? Biggest, right? So we're going to have then from negative infinity up to 3. And because it's okay to be 3, it's going to get a bracket as opposed to a parenthesis because it's an or equal to inequality. How did that feel? Recall doing this stuff in trig and stuff last year? We do this, I think, right at the beginning of the year. All right. The next one says, find the domain and range for the function. Well, we know how to do the domain part, right? So let's do that first. Does the +1 out front here matter? Not to the domain, because adding two numbers, you always get an answer, right? So just like before, here 2 is the smallest number. So our domain is going to go from 2 to positive infinity. Is everybody okay with that? All right. So the next thing I want to think about is this square root part, right? So if I take two numbers like 4 and 9, right? 4 is less than 9. If I square root them, I get 2 and 3. I notice that 2 is still less than 3, correct? So what that tells me is that my square root function is going to be increasing forever, right? As I pick a bigger x and I square root it, I get a number that was, that square root was bigger than the number before it. Everybody's okay with that notion? So what that tells me then is I just have to worry about kind of where this function starts at, because it's going to continue growing forever. Everybody's okay with that idea? So what is the smallest possible x that I could plug in here? 2. How did you find that? It's the beginning of our domain, right? When I plug 2 into here, I get 1 plus the square root of 2 minus 2. What does that turn into? 1. And because the x value is defined at 1, or I'm sorry, defined at 2, the y value should be defined at 1 also, right? That the bracket for the domain should match up with the bracket on the range. And I'm done. Is that okay? Alternatively, again, you could look at, if you looked at this on your calculator, one plus square root x minus 2. And I look at the graph of this. That very first point is 2, 1. I can tell just by reading off my axes there. So 2 is the very first point in my domain. That's the very first x that's used. And 1 is the very first y that's used. And then all the y's get bigger after that, and all the x's get bigger after that. You kind of see how I can use the picture to check what I just did. I think you're allowed your calculator the whole exam, so if domain and range is hard, just look at the picture, dude. Write down what you see, right? It's usually not more complicated than that. All right. Here, same idea as the green one from above, right? I'm just going to take that denominator and set it not equal to 0. Oops. feels okay there. Now here's the tricky part, right? Is that somewhere on here, all the x values are used except for one of them, right? What that probably means is that all the y values are going to be used except for the one that's going to correspond to the missing x. That's usually how that works. Finding that other y value can be pretty tricky, though. Let me double check something real quick to see what they did to do this. Are we just looking at a picture? Oh, sure. Okay. All right, so think about it this way. Think about this as a fraction, right? Aiden, you got to get out of jail free card, it looks like.
Your class is in jail, Mr. Dwarf.
No.
I totally done.
This is my safe place.
I know it's spring break right now. Every time I walk in this room.
This is seriously my safe place.
Thanks. All right, so if we think about this as a fraction, right? The numerator is constant 1, right? The denominator could take any value you want. Agreed? So as a fraction, if I had like 1 over 1/2, I can make that whole thing into 2, right? Or 1 over 1/3, I can make the whole thing 3. Or if it's 1 over 7, I can make the whole thing 1/7. But there's one number I cannot make. If that numerator has to be a constant, there's one number that I cannot make. 0, right? Because 0 is 0 over non-zero number, but there's no way for me to make that numerator not like a constant, because I can't do like the flipping reciprocal. It's just I'm stuck, right? Can't be 0. So again, we write it the same way. Everything less than 0, not including 0, along with everything bigger than 0 that doesn't include 0. And if we had wanted to look at the graph of this, this looks a little bit weird. One, you have to be careful about how you're typing this in. I strongly recommend using that fraction command so you can type it in exactly like it looks on your sheet of paper. If I hit graph now, you'll see that at 2, I have this vertical asymptote. And at x equals 0 or y equals 0, I have like a horizontal asymptote. You guys see that? Just as a word of warning, if you try to type it in like this, let's see what we get, because it's not going to be the same thing. Oh no, what happened? Why did I get the wrong answer? Because this did 1 over x and then minus 2 next to it instead of in the denominator. Got to be careful with how you're typing that in, right? Very easy to make that mistake. All right. What if I did something like this? Oh, geez Louise, Mr. Kulik. All right. So, the stuff underneath the radical, I know has to be greater than or equal to 0. The entire denominator, though, has to be not equal to 0. Everybody agree with that? So if I take those two together, that has to just be strictly greater than 0. Everybody's okay there? Now this is tricky because it's a quadratic. So this is the way that I suggest doing this, kind of in an inequality where you have a quadratic, is I'm going to begin by factoring that quadratic. I'm then going to draw like a sign diagram. So I'm going to pick an x that's less than -3, between -3 and +3, and then greater than 3. And I'm going to plug those in here and see if I get positive or negative values. So if I plug in -4, I get 7 times -1. Well, that's negative, right? If I plug 0 in, I get 3 times 3. That's positive. If I plug 4 in, I get -1 times 7. That's negative. So where is my function greater than 0? In there, right? Does everybody feel okay with that? Okay, how am I going to do the range? When I look at this is not decidedly different than the previous problem, where I have 1 over something that could be almost any value, right? What am I worried about? Probably just 0, but let's look at the picture. I sure hope so. I think I'm being deceived by that picture. Yeah. Yep. I was. Good. So just real quick here, when I looked at the picture, it looks like it's stopping here. You guys see how it looks like the graph stops? It doesn't actually stop there. The graph is just getting so steep that my calculator doesn't have enough pixels to keep up. So what I did was I went back and I said, okay, what if I just plug in like something that's really, really close to -3 and see what's happening? As I continue to get closer to -3, it keeps getting higher and higher and higher, which tells me, oops, that's still wrong, that it was gonna, that's continuing to go up. Should be that though. Why do I know I can't get any negative values? What can come out of a square root? Only positives. What's the numerator? Positive. Positive over positive has to be positive. So I knew I could throw out those negatives. Sorry about that. All right. When in doubt, look at the graph. That's the takeaway. All right. You guys remember inverses? Little bit, okay? So here it says that we have the function x over x plus 4, and it has an inverse 4x over x minus 1. It says to use your graphing calculator to confirm that the domain and range of G is as follows. Okay, well, it's fair enough. So it looks like your textbook isn't going to use intervals like I've been using. Intervals should be fine as an answer, though. All this is saying is all the x's except for -4, right? Anyway, so if I look at this, there's my G. So there's -4 that's missing. There's +1, that horizontal asymptote that's missing. Everybody's okay there? Okay, so that's just me confirming it. Write down the equations for all the asymptotes for the graph of G. Well, I have a vertical asymptote at x equals -4. And I have a horizontal asymptote at y equals 1. Easy enough. Write down the domain and range for G inverse. Here's the great thing about these inverses, is that the domain of G should be the range for G inverse, and the range of G inverse should have been, or I'm sorry, the range of G should be the domain for G inverse, right? So this should be using their notation that they're using here. Is everybody okay with that? That all I did was take the range and change the y's to x's, and then take the domain and change the x's to y's. Done. Right, very easy. It says the graphs of G and G inverse intersect at 0, 0, and at a point A. Use your graphing calculator to find the coordinates of that point A. Okay, so there's my one. And then I'll do the other one here real quick. So I have 4x over 1 minus x. I'll hit graph here. So there's that one intersection at 0, 0. This must be the other one they're talking about, right? So to find that, I press second and trace. I'll choose the intersect command. First curve, enter. Second curve, enter. And the guess, now I have to be careful because there's more than one intersection. I have to make sure I move that close so it finds the one that I'm indeed looking for, and it says that's -3, 3. When I said negative, I meant -3, -3. I think it said -3, 3. And then it says write down the equation of the line that passes through the point 0, 0 and A. Well, what do we need here? I need a slope, right? So y2 minus y1. And I know that since we go through here, 0, 0, what does that tell me the b has to be? 0, because it's the x coordinate is 0, so I know that that y value is my b. So this is just the line y equals x, or 1x plus 0 if you want. I didn't. I think that does it for us, though, for chapter 2. That's all of chapter 2 here today.
Really, that's good. Can we take a test on it?
Yeah, we will.
When?
I don't know, when are you guys feeling testy?
No.
Yeah, before break.
Right?
This could be a very easy W.
Yeah, that's what I think too. So as far as, hold on a second, let's talk for a minute. Let's talk about the homework set for this. Is it a waste of your time for me to ask you to do like all the homeworks for chapter 2?
Domain, definitely need to.
Brush up on. My thoughts were to just ask you to do the review for chapter 2. Does that feel like a good compromise? If you'd like to practice other parts of things, go back and feel free to do more homework. That's the only thing I'm going to ask you to do is to do the review. So that's on pages 48.
I got 4 pages.
And it's 1 through, not very many, 9.
Does that do this Sunday? Or was there other homework due this Sunday?
I don't remember either. But we're supposed to have a quiz on this still, right? I think, let me go look at my stuff real quick. Hold on, let me move this, open this up and look at what I have. Yeah, I do have a quiz for this. I do have in-class examples. I do have, you think,
Do we have to do the quiz on this?
no, but isn't it like a free good quiz grade though? Like, shouldn't you look at it that way?
I do
Yeah,
look
but
at it
if
that
not
way.
coming in, can it replace the test? Just do it.
No, but also that's why I'd like to do the test for this sooner rather than later and just like have that in before we go anywhere for break.
Okay, yeah, I'd say that Friday or that Wednesday before breaks.
Can we do like quiz Monday and test Wednesday?
Yeah. Free day Friday? Free day sleigh day?
Well, I think that there'll be people kind of missing-ish.
Yeah.
That day, so why are, like, I mean,
Wait, what?
they told us at the beginning, there will be no senior skip days, it's like, you will be at marked absence, and why, like.
Okay, I'll be marked absent. I'll be marked absent, I don't care. Oh yeah, I'm not gonna be here Monday. Yeah, I'm not gonna be here.
Okay.
Sorry.
So should we do Wednesday, Friday then?
Yeah.
Okay. I'll put that into the calendar then. That's fine.
I feel like if you already skip a day,